In this video, I'm going to use implicit differentiation to differentiate the example in front of us. Now, implicit differentiation uses Leibniz notation, and so we write that as d over dx, and we apply that to every term in the equation. So d over dx of x squared times y, of that times 9, and that also applied to x times y. And so it's not just something that we can multiply in, it means take the derivative. And the reason that this is important is especially when we run into the case of the x squared y and the x times y. Because in those two situations, what we're actually running into is we're actually running into the product rule. Now, you keep in mind the product rule is when one function is equal to the one function multiplied by the other function. And how we take the derivative is we take the derivative of the first function times the second function, and then we add that to the derivative of the second function times the first function. Writing this out in Leibniz notation looks something like this. The derivative of h of x with respect to x is equal to the derivative of f of x with respect to x times g of x plus the derivative of g of x with respect to x times f of x. And so what we're going to do now is we're going to identify what the f of x and g of x are in those situations where we have to apply the product rule. So x squared is f of x and g of x is like it's y. And then when we have x times y, f of x it's like it's x, and g of x it's like it's y. And so now what we can do is we can recognize that this product rule needs to be applied not just once in this equation, but actually twice. So let's go ahead and apply that product rule, just like I have written in black on the right in this specific equation. So we're going to take the derivative of x squared, the first part of the function, that's the f of x part, times y, g of x, plus now the derivative of the y, so dy over dx, times f of x, which is x squared. That's equal to the derivative of 9 with respect to x. The derivative of any constant with respect to x is 0. And now we look at the derivative of x with respect to x times y. And then we add that to the derivative of the other thing, the y with respect to x times x. So we're just applying the product rule as we see written on the right to this equation. Now I haven't taken any derivatives yet, so let's take the derivative of x squared with respect to x. The derivative of x squared is 2x, and then we take the derivative of x with respect to x. Well, that's just 1, and that's also times y. And derivative of y with respect to x, we don't know what that is. That's what we're trying to solve. So we can't really change anything there. Now we recognize that 0 just cancels out, so I'm going to have the negative as the next term. So derivative of x with respect to x is 1 times y. And then we can't really change anything in that last term because the derivative of y with respect to x is what we're trying to solve. So we don't know that either. Now, so what we're trying to do is we're trying to get the dy over dx terms together. So the one on the left, I'm going to bring over to the right side of the equation, and I'm going to bring the negative y on the right side of the equation over to the left. You can see how I've done that there. So now I have dy over dx times x, and then the one that was multiplied by x squared, I'm going to subtract as I bring it over to the right. So now what I'm going to try to do is common factor out the dy over dx's, but let's common factor on the left side as well. So let's go ahead and apply the common factoring on both sides of the equation. So I'm going to common factor out a y on the left side, and I'm going to be left with 2x plus 1. And on the right side, I can common factor the dy over dx, and I'm left with x minus x squared. At this point, I'm almost done. I just need to isolate dy over dx, so I can divide by x minus x squared. That cancels out on the right, and whatever you do to the right side, you have to do the left side. So we're dividing the left side by that as well. And I get dy over dx now by itself. Now the only thing I'm going to do now is common factor an x out of the denominator. So I get x times 1 minus x is equal to dy over dx. And that is your derivative using implicit differentiation. Have a quick look at the denominator though. Anytime we're left with a fraction, we have to recognize that we cannot divide by 0. And so that means that x can't be 0 and 1 minus x can't be 0. In other words, x can't be 1. And so x is 0 and x is 1 are going to be restrictions. We cannot possibly have those x values for that particular derivative. And there you go. That's all there is to it when you're doing implicit differentiation. I will note though, with this particular example, we could have rearranged it for y and isolated y and then taken the derivative. But it was still a really good example of how you could apply the implicit differentiation. For more videos all about derivatives, including the chain rule, the product rule, and the quotient rule, check out the video on the left. For more videos about calculus that I'm being added to every few weeks, check out the playlist on the right. Thanks so much for watching, and I hope that was helpful.